WASSCE 1993, May-June, Elective Physics. Question number 1. A. Define density of a substance. B. If 25 centimeter cube of a quantity of marbles has a mass of 45 grams, calculate the density of the marbles in kilogram per meter cube. C. A particle starts from rest and accelerates to velocity of 5 meters per second in 20 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in a further 10 seconds. I. Draw a velocity time graph of the motion. II. Calculate the initial acceleration of the particle and total distance covered. Solution. The first part of the question A says we should define density. So density is defined as mass per unit volume of a substance. So mathematically, it is defined as density is equal to mass over volume. B. If 25 centimeter cube of a quantity of marble has a mass of 45 grams, calculate the density of the marbles in kilogram per meter cube. Now, the mass has been given in grams, so we have to convert it to kilograms. And then the volume has been given in centimeter cube. We have to convert it to meter cube. So that is what we are going to do. So we say that B, volume of the marble is equal to V. So V is equal to 25 centimeter cube. So we are converting this 25 centimeter cube to meter cube. So it will be 25 centimeter cube over 1 million, 1 million centimeter cube times 1 meter cube. So this is equal to, we divide this by that, we are going to get 0.1234 and then 25 meter cube. Mass and convert. So the mass of the marble is equal to M. So M here is equal to 45 grams. So it's going to be 45 grams over 1,000 grams times 1 kilograms. Grams cancels grams. So finally, we get the mass to be 0.045 kilograms. Therefore, density of the marble is equal to, this is equal to M over V. The M we have already defined, V we have defined. So the mass, which is in kilograms, is now 0.045 kilograms over the volume, which is now in meter cube. Then we have 0.123425 meter cube. Now, when we divide, we are going to get 1800 kilogram per meter cube. C. A particle starts from rest and accelerates to velocity of 5 meters per second in 20 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in a further 10 seconds. I. Draw a velocity time graph of the motion. Okay, so solution. This is velocity time graph. Every graph has a title, so you have to write velocity time graph, then you underline. So now for the velocity time graph, we have the velocity on the vertical axis and then the time on the horizontal. So this is velocity, that is meter per second, and this is time, we have it in seconds. Okay, and we are told that this is the origin 0, 0, time 0, velocity 0. We are told that the particle starts from rest and accelerates. Now, in velocity time graph, this, a line that slopes positively like this, stands for uniform or constant acceleration. The line that is vertical and parallel, a line that is parallel and horizontal to the time axis represents constant or uniform velocity. And if the line lands negatively, it stands for uniform deceleration or retardation. Okay. So we are told that the particle starts from rest and accelerates. Starting from rest means velocity 0, time 0, and accelerates. So acceleration goes like this, uniformly. And then to a time which is 5 meters per second. So this is 5 meters per second. And we are told that in what second, in what time? The time is 20 seconds. And we are told that it maintained this constant velocity for 10 seconds. So 10 seconds. Here we already have 20. So 20 plus the 10 gives us 30. And then the question says that it decelerates to rest in a further 10 seconds. So this is the deceleration to rest in a further 10 seconds. So further 10 seconds is 30 plus 10. So this gives us what? 40. So this is the velocity time graph for the motion. II, calculate the initial acceleration of the particle and total distance covered. Okay, so we say let A is equal to initial acceleration, which we are yet to calculate. U is equal to initial velocity. And then the initial velocity is 0 because it's initially at rest. So it's going to be 0 meters per second. Now, final velocity V is equal to the 5 meters per second. 5 meters per second. And then time taken for the acceleration is the 20 is equal to 20 seconds. Now, acceleration is equal to final velocity minus initial velocity over the time for the acceleration. So, acceleration is equal to final velocity, which is 5, minus initial, which is 0, over time, which is 20. That is meters per second squared. So this acceleration is equal to 5 over 20. 5 goes to itself 1, goes into 24. So the acceleration here is equal to 1 over 4 meter per second squared. Better still, we say acceleration is equal to, when we divide this by that, 0.25 meters per second squared. The second aspect of the II question says that we should calculate for the total distance covered. So we say that therefore, the total distance covered is equal to D. Now, in velocity time graph, the distance, total distance covered, is the area under the curve. And then the area under the curve is a trapezium. So we are going to use the formula to determine area of a trapezium to calculate for the distance covered. So we say that the total distance covered is equal to D. So D is equal to half times sum of the parallel sides. These are the parallel sides. We sum. When we sum this one is 10 plus from here to here is 40 times the height, which is 5. Okay, so I bring this and then I bring meters here. So we have D being equal to, now let us multiply the numerators. So when we multiply the No, first of all, D is equal to 1 over 2 times, we add this to this, it gives us 50 times the 5 meters. So the D is equal to, when we add the numerators, it gives us 250 over 2 meters. When we divide by 2, it gives us 125 meters. So the total distance covered by the particle is 125 meters. Subscribe, like, share, and discuss with your friends. Thank you.